started. Welcome everybody. On this webinar, we are going to cover Modelplace.AI and how we do testing and integration in Modelplace.AI. This is a brand new service from OpenCV where sellers of the model can upload their own models so that buyers of the model can test it out. We have a ton of models already on the site where you can test it out and check out for yourself. But in case you're interested in selling models, you can also join the site and send us a request. So this is a brand new public release. It just happened yesterday, or the day before yesterday. And we are very excited about it. And today we are going to reveal what goes under the hood. How do we make it performant? What are the tests we do, etc. And joining me are Anna Petrovicheva and Alexander Lyashuk. So who are, they are the core developers on this task from not just, the technical development, but from the inception, the conceptual, how this thing would work. Anna and her team, they pretty much did everything from the conception all the way to delivery. So they know this thing in and out. Anna, I'd actually like you to give a brief introduction of yourself and also pronounce your name correctly, as I did not. Same thing with Alexander.
Thank you. So hi, everybody. My name is Anna Petrovicheva, and I'm a co-founder of Modelplace.AI. I've been with OpenCV for the last 11 years of my life, doing computer vision and deep learning for different projects in different industries, from autonomous driving all the way to medicine diagnosis. So somewhere during the way I got this idea that it would be super cool to democratize the way we actually apply artificial intelligence into some real life products, right? So that it doesn't become a huge hassle to integrate artificial intelligence based algorithms into something that works. Along this, when we started working on this idea that later became the Modelplace.AI, we also understood that it would be super cool to not only integrate faster, but also test the ideas faster. Because right now it takes several hours or even days to download something from GitHub, test it out, like make sure the environment works, you can reproduce the result, and only after that test it on your data. So this is basically how the Modelplace.AI was born. I'm pretty much inspired, like in my work, I'm inspired by how to make models reproducible and how to make artificial intelligence reliable work in a predictable way in the real life solutions. We will basically talk about how to test a model on the example of how we test models in Modelplace.ai to make sure that we provide the users with something that works, right? Not only works on one image, but works every time, all the time, for like any types of images. Okay, so this is me. Alex, would you like to introduce yourself?
Sure, my name is Alex, and I'm leading the development of Modelplace.ai. And as Anna said, a lot of words. We are trying to make models reproducible, so everyone, no matter whether a user wants to join the site to test an image on a different model, use drag and drop, or, for example, if he or she wants to download the model from the site, we want to make sure that the models performs as expected.
Cool. And as always, we also have Phil Nelson with us, who is the content manager at OpenCV, and he manages all these events, our blogs, etc.
Howdy, everybody. As a reminder, at the end of the webinar, we'll be doing Q&A with the panelists from the audience. We've also got a giveaway at the end, and we'll tell you what you'll win at that time.
All right. And I'm Satya Malik, because I always forget to introduce myself. And if you want to know the real Indian pronunciation of my name, it is Satya Malik. And if you want to know the real pronunciation, how they will pronounce it in my hometown, in my village, it is Satya Morika. You see? So it doesn't matter you know, how the actual name is mangled. I don't actually care. I just want to make it easy for people to pronounce. So we were just having this discussion before the webinar, how I'm going to screw up everybody's name in this webinar.
There's an old Monty Python bit about name pronunciation that it's actually, my name is spelled Raymond Luxury Yacht, but it's pronounced Throat Warbler Mangrove.
That's funny. All right, so let's get started. Alex, can you share your screen? And we'll get started on what's under the hood.
Yeah, let me first start with the idea on why testing matters, right? Deep learning and machine learning are very, very much developing like new parts of software development industry, right? In software development industry, there is DevOps, and there are people who are responsible for making sure that software works, right? They have a lot of code culture. They have a lot of ways to make sure that their software doesn't break in real life. And they have more years to develop this kind of culture. In deep learning and machine learning, this is not the case. Many people still develop kind of separate development of models and their productization into two completely different things, which in many cases leads to the following. So imagine a machine learning scientist who develops, for example, a Jupyter notebooks, and it works okay, right? It works on the data. They can showcase how it works to their management. Management is satisfied with the results. And then they then they move this task to the productization team, and they cannot reproduce the results, right? They cannot reproduce the environment where it worked. They need to go the full way and re-implement it from scratch in a different language, and they have very little kind of control about on the system. Now, I'm a fan of a slightly different approach. I think that even though we are data scientists and deep learning people, allowing to create algorithms and not do infrastructure work, we still need to implement tests for the work we do, and we are obliged to writing a very high quality code. Right? We need to have code culture. We need to make sure that our code is not only writable, but also readable and stuff like that.
Actually, that's a very good point. As a software developer, most of the time you don't write code, you read code. And when you find good code, it's a pleasure to read. Otherwise, it's hell for you.
Yeah, and like there is a research about that you spend as a software developer, you spend way more time reading code, your code or others' code, right, than writing the code itself. So it makes total sense to make sure that your code is something you will want to read in the future one more time and not be embarrassed about that. Yeah. But this kind of code culture is not only about reading the code, it's also about making sure that other people or you in the future can get just the same results of your experiments than you have right now. And yes, it needs some specific effort, right, to be done, but it pays off, believe me. In the long run, this definitely pays off. So I do believe that we need to implement tests, that we need to have some procedures. For example, when doing merge requests, we need to conduct the full testing, ideally in automatic way and stuff like that. Now, the state that the industry is in, it's definitely improving. I do see this positive tendency in the last 3 to 4 years when the research becomes more and more reproducible. But I would say that the industry is in the state when you cannot always reproduce the results that other people claim, for example, in papers. So several years ago, I was at machine learning conference speaking about MLOps, which is very similar to DevOps, but works with machine learning algorithms and code. And I was speaking about 80% of the papers not being reproducible at all in my experience. Right now, I would say the percentage definitely decreased, but it's still pretty high. So the typical situation is the following. You go to GitHub, you download the code, you spend several days even to reproduce the environment, download all the libraries, set up everything, put the data sets in the right shape. And then when you run the script, you don't get the results that people were claiming in their paper. This script either fails with segfault or doesn't work as expected on the very same data. And you start second guessing, writing to the issues, trying to talk to the author, stuff like that. So in most cases, obviously, the results are worse. But in one case, in my experience, the result was actually 5% better, right, than reported in the paper, which was super surprising.
Right.
So yeah, I would like to live in a world where it's easy to reproduce the results, because it's not only about the convenience, it's about building on top of each other's work, right? To build on top of someone else's work, you need to be sure, you need to be sure that the results they reported are the same that you get, right? And this is basically it goes all the way to collaboration, right? We need to be able to collaborate all together. So testing matters. I hope I spoke enough about that. Now, in Modelplace, as I told, is built on this idea of being able to work easily with the code, artificial intelligence related code. But when building this system itself, we try to incorporate these ideas into our internal processes. So Alex is in charge of the software development on Modelplace side, and I will let him talk about how we test the models inside the Modelplace.
Thank you, Anna. Okay, so to begin with let's first go through the typical pipeline. For example, you have a computer vision task you want to do with deep learning. What would you do? As Anna said, you will go to papers with code. Maybe you will read an article. Maybe you will just find some links or on GitHub. So the thing is that you will be searching for the model. All right, what's next? You have to find out how to install the model and how to use it. That can be absolutely different from one model to another, from one repository to another repository. So here's an example on an animation. For example, on the left side, you can see that Moscow CNN model on papers with code. We go to its GitHub repository and we have to find the installation guide. Then we have to go through some Jupyter notebooks to understand how just to run the model. The thing is that you installed all dependencies, went through getting started guide, and you have already spent a lot of time, but you still don't know whether this model performs well or not, whether it works on your data and works at all. You don't know it because you didn't try. You installed everything, but you still need to try it. So, okay. In Modelplace.AI, we try to overcome this. You don't need to install anything. You just, the only thing you need to do is to use drag and drop interface to understand whether this model will be working on your data or not. If it's not working on your data, or if it works probably bad on your data, like you have a different data set, and the model doesn't perform very well. So when you provide a model, you must be sure that it works both on the website and will be working if you download it from the website, right?
Yeah. I can also give another example. For example, person detector. You may think that, oh, YOLO person detector, whatever was trained, would directly work on your data set. But as soon as the camera angle changes, let's say you're looking at a security application where the camera is looking down at the person, and if the data set doesn't have enough of those examples, it's going to fail miserably, right? So you would do all the work for installing this thing, and then it would not work, right? And then there could be other things like performance issues also for you may be wanting to see whether it works on Raspberry Pi. And if you use a bigger model, then it would not, right? So yeah, go ahead.
Yeah, and one more thing that as Modelplace.ai is a marketplace for a model where everyone can publish their model on the website. So we are, as a developers, as a service, we must be sure that this model published by external artificial intelligence developer will be working as well on the website, and if someone wants to get it. So as a marketplace, AI models are the main component of our product. This means we must be careful to ensure the functionality and performance of every model released, or users will lose the confidence in the service. Of course, it's much easier to developers when you have some automated systems, because it reduces bugs and just simplify the development. Okay, so what we have integration tests. Integration tests we need basically to make sure that drag and drop is working. I mean, if we speak about the models, of course we do integration tests to make sure that sign-ups, that you can log in, that you can get task result, and that visualization works, and everything is working. That's why we use integration tests. Unit tests we use to make sure that the provided package is working correctly. So, and that's not it. The thing is, okay.
Alex, one more thing. So for people who are new to software development, etc., they may want to know, what is the difference between a unit test and integration test. And correct me, if I'm wrong. I'll just explain at a very high level. Unit tests you use when you want to test out a functionality, right? Small pieces. So in your code, you have many different small pieces of code that need to work. And we have unit tests for these individual pieces, right? And that's why it is called unit, as in a single test, right? And then you have integration tests, which actually tests the entire system working together. And so you have these different kinds of tests. Even if the unit test passes, sometimes it's possible that one piece is not working with the other, right? So you basically do the test at some granular level first, and then make sure that the whole also works. Is that a fair way of describing?
Yeah. Okay. Just want to add that, for example, if we are speaking about the models, unit test is just, for example, we have a function, a method named like process sample. We must be sure that this method, just this small method works.
Yeah.
When we have the website, we must be sure that it goes through the API. So we send the REST API method, and we make sure that it goes through databases, through the backend service, through the front end, and through everything. So this is like an integration thing. So here the difference is that when we do unit testing, we just make sure that one single small part of our code is working. Yeah. When we use integration tests, we make sure that the whole system is working.
Yeah. Okay.
I have a quick question as well.
Okay.
I know there's so many different testing frameworks for Python, like unit test, PyTest, PyUnit. What can you maybe talk briefly about what you're using on the backend for that?
We are basically using PyTest because it's much easier to support, because it has a lot of features like fixture. So you don't need to use some object-oriented programming things to write test. With PyTest, it's enough just to have a function named test underline something. So like, for example, test underline process sample and things like that. And you just run PyTest from your terminal, PyTest and this Python file, and that's it. You don't need to do anything complex to do testing. And this is another advantage of this, that this is easy to, when you look at the code, you understand it, like you understand what it is doing. You don't need to go through the classes, to go through the objects and the things like that. And the fixture are great, actually. If fixtures are great, if there are some Python developers in our webinar, they will understand what I'm talking about fixtures, because this is a really useful thing.
Okay, thanks.
Okay, let's go ahead then. The thing is that that's not it. I mean, we already discussed some integration tests and the unit test, but also we as artificial intelligence model is our product that we provide to our users. We want to measure the performance of a model and its quality. So, for example, if you find a model, like for example, you have first of all, you need to understand how the model generalized on a data set. So, for example, you see that the model works well on synthetic data, or otherwise, for example, you can see that the model really works with some real objects, like. Or, for example, you need to understand that this model performs well on a specific data set. Another thing that you need to understand, for example, if we speak about computer vision things, we want to know how many frames the model can process per second. So this is like a performance thing. And when we are doing some business things, we have some requirements and limitations. So that's why this is really important. So the metrics allow us to rank models by score and the performance time based on benchmarks. We currently don't have this information public on our Modelplace.AI, but we plan to add benchmarking in future. So it will be easy for everyone to just use some filters to understand what model to choose and what model will be better for specific purpose.
That's huge because now you don't have to do your own tests. You can just look at these are the numbers for object detector for they have similar accuracy, but the performance, the speed is much higher in one case, and you may want to choose that. And it's also possible that some of these things are optimized for certain platforms, and so you would use the optimized version for that platform.
And I'd like to stop here, but that's not it. Again, that's not it. That's not enough. More tests for. Okay. On Modelplace, we have a list of models that specifically support OpenCV AI Kit. So when we provide a model for a specific device, this is not a Python wheel that you can provide for like different platforms, different operation systems. When you have Oak, it's necessary to test these models that has been provided for Oak. So you must be sure that they are working on Oak. So we test the model, for example, on Oak 1 or Oak T. And what we do that we have this Raspberry Pi plus Oak 1 system in our office where we test each model we provide for OpenCV AI Kit user. So let's get it all tests together. So what we have integration tests. As far as we said, we use integration tests to make sure that the website is working and the all models provided that are provided there working as expected. Then we have unit tests. Unit tests we need, for example, if someone wants to provide the model, we can't publish the model before we do this testing. And we have unit testing we have like a trigger in our GitLab CI to test the model on every commit. So one more thing that we have is performance tests. So to make sure that the model works well, works fast. If it's not fast, we will just provide the details that like time consumption of model inference and things like that. And one more thing is benchmarking. We must be sure that the model we provide, to provide the results, how this model performs on a specific data set. And the last one we have here, maybe we will have more tests in the future, but currently the last one is on-device test, and we have more than 20 models on Modelplace.AI that are specifically designed for OpenCV AI Kit, and we test each model published on Modelplace.AI on Oak One with Raspberry Pi 4.
So in normal software engineering, you usually have integration test and unit test. But if you're trying to do an AI-based system, it needs to have these additional 3 tests. Sometimes you have performance tests and regular software engineering also. But for AI-based systems, it is absolutely necessary that you test the performance, the speed of the new model that you might have done, and also run it across benchmarks for data sets. Because if you publish a new model and it is you don't have a way of automatically checking whether the new model is better than the old one, then it's just going to be disastrous, right? You always need to have an independent test set on which it is benchmarked. And finally, on-device testing is also crucial if the model has been certified for a device, which we plan to do. We already have on-device testing for OpenCV AI Kit, but we plan to add it for other devices as well. So it's a pretty solid system. You test all of these things, and they are continuously automatically tested. It's not like some human is going and testing these things. So Alexander will show, what are the tools we use next.
Yeah, to make it efficient, we use continuous integration, of course, so we don't run tests manually. It's necessary to be sure that the development of a new model didn't impact the existing models. For example, you developed a new feature and you don't want that this new feature would be the reason why your other, for example, you improved your, for example, PyTorch backend, and one of your 40 PyTorch models started to work very well, but your other 39 models didn't work at all. So for this purpose, to make sure that all the models are working, we on every commit we have a set of tests that build models and run unit tests for each of them. So kind of here is you can see the screenshot of GitLab repository. And one more thing here is that we have, of course, that we don't provide only models. Of course, we have some things like infrastructure. For example, we use Kubernetes clusters to be able to auto-scale the loads when a lot of users want to use drag and drop interface. Also, we have code linters and the things that measure scores of how we write our Kubernetes manifests and things like that.
And for people who don't know, Kubernetes is basically a mechanism for auto-scaling your system. Let's say your system was designed for 10 users and 100 users show up simultaneously, then it will auto-scale, it will provision machines, etc., and resources so that it auto-scales to allow 100 users to use it. And if the load goes down, it automatically downscales as well. That way, you're not running out of space, you're not running out of computational power, etc. And those things need to be very heavily tested before you deploy them in production.
Yeah. Okay, then. Here, I'm going to show you an example that shows the test that helps you to be sure that the product works as expected. For example, here you can see that we downloaded the model from Modelplace.AI. Then we use the code provided on its model page, just how to try it on your device. So we just copy and paste this code, and then just run it. And here we see that it's the same from our website and the Python wheel we got from the website. So the thing is here that it's much easier to do compared to the first slide that I showed, when you have to find your model on papers with code, then you go to GitHub, then you download, install any dependencies, and understand how just to run inference. Sometimes you need to find or ask for the weights from the author, or just sometimes it's just difficult to download the weights just because it's basically they are not stored on GitHub repository and they're stored in an external resource that can be unavailable, or just you need to, for example, ask a permission to download these weights and things like that. So just want to say it one more time, that the model can be placed on Modelplace if tests are failed. And to conclude this, just want to say that it's difficult to overestimate the importance of model testing. Unit tests allow us to make sure that the model works correctly as a standalone unit. And integration tests verify that the model works within the entire product pipeline. So API is working, the website is working, everything is working as we expected.
Yeah.
We also evaluate the quality of model prediction on public benchmarks in order to rank models and make sure that they generalize well. And we have some other systems, for example, specific tests that are run on device to make sure that if you download this model, for example, Oak model that you like, we make sure that it will be working on your Oak One or Oak D. So that's probably it from my side about testing, and I think that.
So one question, Alex. What when we built this integration, a continuous integration system, could you explain some of the details of the system, like how is it implemented? What tools do we use? The interface that you showed.
Okay.
What are the tools involved? Yeah.
So basically, when you integrate some continuous integration things, for example, if you are doing it in a GitLab ecosystem, you need to set up GitLab Runner. We have GitLab runners on our own machines, and we have also GitLab runners in our Kubernetes clusters. So the thing is to put some manifest down on GitLab-ci.yaml file, where you set up different jobs. For example, the first thing that you have to do is to do linting. So your code was understandable by other developers, and it was just clean. So that's why, for example, the first stage is your code linting. If some tests there are failed, you won't be anything else. You will not go further just because it's failed, and you must, before this, you must make sure that code linting is passed.
Right. And what kind of, for beginners, what kind of things does this code linting test?
For example, you have some, this is actually syntax thing. Like, for example, you have a lot of spaces, a lot of like a lot of things, like for example, wide code. I mean, or I don't know, like actually any syntax things depends on the linter you have.
Yeah.
Probably some import. I mean, how you do imports. Maybe I mean, from company to company it depends. For example, some of them prefer to use alphabet order to do this, and some other things. So you don't actually have linting only for Python code. You as well have linting for your Kubernetes manifests, or even actually Markdown files, just because you want your Markdown files looks pretty good for other people. So
it is mostly for consistency, not really for correctness, right? It is
yes,
all the developers are using the same kind of the same kinds of, they're using spaces in the right way, comments, etc. correctly, not using very long lines, those kinds of things, right?
Yep. Yeah, kind of. Yeah.
And then we have, then the second one, could you go back to that slide where we had four different things that we were, so here, what exactly happens, right? So where do these people see this particular interface when in our system?
I mean, this
what
is
the screenshot of?
This is internal code of our. Actually, we have a mirror from our GitLab to GitHub repository. This one is about our Oak repository. And here we have some tests. For example, some of them are failed, and it's okay. I mean, we have some tests. For example, you have Deps.AI dependency, and your code is working on some specific version, but they will update their code, they will update their API, and then your code will not be working just because they changed something. And we are sure here that for example, before mirroring this repository from GitLab to GitHub, so I mean available to everyone, we internally test that all the models provided for Oak is working and the tests are passed on a specific device.
Right.
Yeah. I would probably show more pictures about our internal things like API but I can't.
Okay.
For privacy thing.
Right. So in terms of tools, what are the, I mean, if let's say I don't know anything about unit testing or these kinds of things, and I have code, I have written code, I have put it on, GitHub, and I want to implement a continuous integration system where whenever I deploy a model or whenever I change my code, it goes through these unit tests, right? What are the tools that I need to complete the process? Can we list them out? And then Phil will, link to them in the YouTube channel also.
Yeah, okay. So the thing is that it depends on like what you want. If you use GitLab ecosystem, you would probably use GitLab Runner and this thing. If you have a GitHub repository, you will use probably GitHub Actions and the syntax of GitHub Actions to set up. On both GitLab or GitHub, you can see the docs, documentation, how to set up. Okay. And the thing is that you decide what you want to run and how you want to run it. For example, you want to, like there is two things, continuous integration and continuous delivery. For example, for continuous integration, you do tests and they probably will be run on every commit, or some additional tests will be run when you create merge requests and things like that. You don't need to run deployment jobs just because this is continuous integration when you integrate new features. But when, for example, you create a tag or create a release, you want a trigger. So when you create a tag, the automated deployment, you want to run automated deployment for this thing.
Yeah.
So this way you set up how, I mean, the thing here is you decide what you want and how you want to test and to deploy.
Right.
You can't just say, for example, GitLab or GitHub do the job for me.
Right.
You of course have to, if you're speaking about continuous integration, you have to write tests. Without tests, you can't run anything. And if we're speaking about the deployment, you have to implement, for example, Terraform, like deployment with the Terraform or with the Ansible or whatever you want, or probably you just want to use your maybe Bash script, and that will be enough for you. But the thing here that you decide how your continuous integration and the continuous delivery will be working. Actually, as we mirror our repositories, you can see the config in our GitHub repository. I will send you the link just in a moment. I will share it. One second. So here we have a GitLab CI file, and we have linting, build packages, test packages, and mirror stages. And we do code linting everywhere instead of main and develop branches.
Mm-hmm.
Then we do build packages like always. We always want to build packages just because if we choose anything, we want to build it.
Yeah.
Then we do testing. We do testing on like always.
Yeah.
And the mirror main we do only on mirror on main branch. So for example, if we internally make some commits to main branch, it will be the pipeline will be automatically launched, but only if the tests are parsed. So if it's not, no deployments, just because we don't want our users to be upset about some.
Right. Right.
Yeah.
Cool. Yeah. So that's a lot of information. And one last question before we let users ask questions as well is what does our software stack look like? What are the various, which web server we are using? Could you explain the various components?
We are using, we develop our API. The Python is the main stack that we use, of course, just because a lot of models are provided by Python packages and things like that. So, but we also use Nginx as a web server, just because we want to set up headers, we want to set up limits,
right,
and to avoid DDoS and to avoid some brute forces and things like that.
Yeah.
And we use modern front-end frameworks to develop our website. And what else? And we use Terraform and Ansible to deploy our changes to production and developers' stands.
Okay, great. So we'll
maybe talk a little bit more about Ansible. I'm not sure everybody knows what it is.
Ansible is like the thing. For example, to understand it, so it will be more easily to understand. I will say like this. So this is like a playbook, and you there have some commands. For example, do this, do that, and it understands you. something like this. This is like the basics of Ansible. If we speak about Terraform, it's a bit complicated just because we have states, we have the whole infrastructure inside manifest. So this is like the concept here is infrastructure as code. So we have this, for example, that we want to use specific machines for our API, for our backend. We want to use specific machines for our, for example, Oak models, and we want to use specific machines for some, for example, GPU models that probably will work on with the video data. So it performs faster. So we have this thing in Terraform that we have a lot of node pools, and we can describe it here in a file. So for example, when you develop your system, you can typically do two things. The first one, you will go just to use your front-end interface, web interface in a web browser, and you will just go, for example, if you use Google Cloud Engine, you will go there, and you will just set up by clicks and things like that. If you want to, for example, to move from one provider to another, or if you just want to replicate your cluster, or you want to do like anything with this, you can't control it just because one developer changed one thing and another developer changed another. And when you have this, for example, Terraform and Ansible, you have your whole infrastructure as code in a repository. So this is actually great and easy. So for example, if I want to change a machine, for example, from specific model, I, for example, decided that on a different machines, it will be working faster, for example, and that's okay. So the only thing that I do is just create merge request from one branch to another, and that's it. And for example, if I want to move from Google Cloud Engine to Amazon, no problems for me. I just change some credentials, for example, from Google Cloud API to Amazon API, change some machines because they are named different from Google Cloud and Amazon. And of course, I need to change something, but I still have all infrastructure just in front of my eyes. I can see the screen and I can see this manifest with this JSON or YAML manifest with the whole infrastructure.
So it makes it much more portable and much, you can move between services more easily, etc.
Yeah.
So we learned not only about how machine learning is done, but also a lot about software engineering deployment, which is not tied to a particular provider, right? That really helps people. I think that's really good, really good practice. That when you build something like this, you build thinking that tomorrow, if you have to move your infrastructure to some other provider who's giving you $100,000 of free credit, it is easy to do it, right?
Yeah.
Okay, I think we should open it up for questions from our users.
Shall we do trivia first?
All right, trivia first.
So will you like to tell them what they'll win if they answer the trivia questions, Tia?
Yes, so yet again, I'd like to say that our Kickstarter campaign is just 48 hours, will end in 48 hours. And this Kickstarter campaign is for OpenCV for beginners. So we will give you a free copy of OpenCV for beginners when it launches. Last time, I think I made a mistake by saying that it will be available in July. It's actually going to be available in September, but you will also receive a free copy of Computer Vision 1, which is an introductory course in computer vision. It's a solid course, takes about 3 to 4 months to complete. And this will be available in July. As soon as you win this, in July, we will open it up to you.
Awesome, thanks. So hands-on buzzers. The way this works is I'm just going to ask a trivia question based on something from the presentation. The first person to answer correctly on my screen in the chat will win what Satya just described. So the question is, earlier in the presentation, there was some discussion about Python testing frameworks. What Python testing framework does Modelplace use?
Oh, God.
Quick. I see it looks like Bjorn one on my screen here, and even used the proper camel case. Well done, Bjorn. So we'll be in touch with you after the webinar here. Thanks for answering. So we should move on to questions and answers from the audience. A lot of people were asking about how to get models listed on the site. Like, what are the requirements for them if they want to submit their own model?
So right now, this is a manual process. You need to talk to us. We will send you the instructions. Basically, you will need to convert the models into the ONNX format, and then we will be able to deploy them into our infrastructure, meaning that we will deploy them to the cloud, and people will be able to test the picture, test using their pictures with drag and drop on our site. But yeah, please talk to us. We have contact form on the site.
Yeah, and we wanted to be very careful not to automate this piece. We want to make sure that all the models that are going into the system, at least in the beginning, we get a flavor of what they are. If there are things that we need to optimize, we just wanted to be careful not to automate this part. We want to see everything that's going into the system.
Yeah, that makes sense, especially in the early days. You really want to be, much more tight on how you what you integrate. Thanks. So how are these? A lot of people are asking about training as well. How are the models on the site trained? Is there any specific requirements for that? And also, do all of these models or some of these models have the training data available?
So the answer is no. At this point in time, Modelplace is only about supplying the tools for inference, right? So we are only focused on this side of things. Having said that, so some of the models that you can see on the site are taken from open source places, right? Like GitHub, and we put all the links to every model there. And yes, for these models, you definitely can access their training sets.
Great. Good answer. We talked a little bit about Python linting, Alex, earlier. What linter does Modelplace use?
We have a lot of linters actually there, but the common one is black, and isort, something.
Yeah,
like
I mean,
this.
there's so many of them, similar to the testing frameworks. Like there's Flake 8, there's Pep 8, there's a ton of them. Thanks. Another question about infrastructure. Is there any way for, are you planning to provide benchmarks for, say, running on certain hardware, like, a big beefy GPU versus a CPU in the future on the site?
The answer is a big yes. This is one of our kind of favorite topics. We want not only solve the kind of problem of hard integration into real pipelines, but also make sure that people choose their models wisely. Right now, it's hard to choose the model that works best for you, but we want to kind of make sure that it's easier. It's not going to happen in the next week or two, that's for sure. But this is our plan on the future features.
Yeah, and companies, it might be hurting our business because companies spend a lot of time just figuring this out. I can't name the details, but there is one company that will spend about $50,000 with us trying to figure out which is the best model to start with, just for that piece, right? They have to do all the benchmarking, etc. And there is no other option, for that particular kind of model. We have to go and test everything that's available out there. And Modelplace.AI will make it so easy for people to do this specific kind of thing.
And in many cases that I saw, in real life, people just choose something they heard about, right? So, for example, YOLO is very, very popular, and people just choose YOLO, even given that it's not best in like all different cases that can exist.
Yeah, Anna is not a big fan of YOLO.
I mean, YOLO is great, but I'm more a CentreNet person.
Yeah. Thank you. People are asking about hardware as well. So you talked about how OpenCV AI Kit is supported on the site in a unique way currently, where it's got continuous integration directly on the hardware, and many of the models are specifically OAK certified. What other hardware are you planning to add support like this for in the near future? Can you be more specific about the platforms?
So, like to be honest, that's an open question. So probably the first to go will be mobile devices, Android and iPhone based, right? So we'll be focusing ARM. It's probably an ARM era right now, right? We have ARMs everywhere, so that it makes total sense to do so.
So Anna, would it be more embedded compared to say, big GPUs? Would our focus be first add embedded devices, edge devices, etc.,
Okay.
and later move on to GPUs, or what are your thoughts?
So right now we have a support for on-premise inference on GPUs and CPUs using Python Rails, but the edge, the edge devices are covered by OAK. In future, we will probably focus more on edge devices.
Okay.
Cool. That makes a lot of sense to me. People are also asking about requirements for, so many of the models on the site you talked about, you can actually download them, a Python wheel package. What are the requirements for running those locally?
Okay, so basically all the requirements are supplied to get along with the model, right? So if you download it for on-premise inference, there is a requirements file for Python environment. If you run it if you download it from GitHub, from our OAK model samples repo, there is also a README that kind of walks you through the process and gives you all the things that you need to do to reproduce that.
Awesome, thanks. So there's, I think we got time for one more, right? Yeah. People are asking about, can you maybe compare and contrast, describe how Modelplace is different from, say, TF Hub, the big TensorFlow kind of model clearinghouse?
Sure. So one of the things, there are several differences and there are similarities, that's for sure, right? So we both are kind of hosting models that are targeted for different use cases. One of the things that we would like to accomplish with Modelplace is to make sure that developers from all over the world can monetize on their skills or their unique data sets that they have. And we really will be pushing into this much more, right? Because we do see a huge interest in this area. There is a kind of huge pain there because right now it's really hard to monetize skills that are definitely on demand somewhere else, right? So there is no market for this yet. The other thing is because of that, right? We also want to have many different use cases covered on Modelplace. So right now it's pretty there is a lot of general purpose semantic segmentation models out there. But if you are working in specific field like quality assessment on manufacturing, it's really hard to find a model that would work for that. In the same time, there are definitely models out there in some hands that will solve your problem. So we want to make sure that these specific real life problems can be solved.
Yeah, I would actually like to add one more, just emphasize what Anna just said, that there's this long tail of people, when Google publishes something, it is to solve what millions of people need, right? And that's fine. But when there is a marketplace, you think about it as eBay, right? Where you can find things which only a small number of people use, right? And Google would not be interested, or any large company would not be interested in publishing models for those tasks that are of interest to, let's say, 10,000 people, right? They need a scale, they will publish models which are large scale, right? They are used by a lot of people. But we are enabling people, small communities to connect with other small communities with common interest, right? 10,000 people is pretty big for us, and we are covering the long tail of these models, right? So that's another thing, just to add some more color to what Anna already said.
I also wanted to say that there will definitely be a revenue share with the creators who provide their models. Basically, we will be using a standard scheme via marketplace. So we will be having some commission to the sale, but most of the money will definitely go to the creator of the model. This is the idea.
Yeah.
Great. If people have more questions and they want to reach out, Alex and Anna, what are the best ways for them to do that, to get in touch with you?
So we have our emails, right? So my email is anna@opencv.ai. I will be super happy to receive your messages, and also please feel free to contact us through the Modelplace site. There is a contact form just for that. We answer everybody.
That explains the 16-hour days since the last 2 days.
Thanks. So I guess we're out of time. Satya, you want to take us home?
Yeah, thank you so much for joining this webinar. Thanks, Anna, Alex, and Phil, as always. And please check out Modelplace.ai, and we will bring more interesting, under the hood kind of webinars in the future also. And that's it. Finally, a quick reminder, our Kickstarter campaign ends in less than 48 hours. Please check it out as well. That is it. Thank you.
We'll see you again next Thursday, 9 a.m.
Bye. Thank you.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Modelplace.AI, the AI model marketplace by OpenCV. Learn more at Modelplace.ai.